Is this audible?
Yes, it is visible. It's not audible.
It's not?
No, it's not audible.
1 second. 1 second. Hello, Rekha, was it audible?
But it's not audible. No, it's not audible. You are audible, but your presentation is not audible.
But it's then the same thing as what you were facing, because when we run the presentation. I'll try again. Sorry.
Yeah, please try it again.
Now?
No, it's not audible.
Okay, I'm sorry. Chris, will it be possible to, sorry for the interruption, but Chris, will it be possible for you to give the presentation on its own?
Yes, sure, I can do that.
I'm sorry. I'm sorry.
Can you get to the previous slide then? Okay, well, thank you very much, everyone. Hope that the real me is audible in place of the recording me. And it's a privilege that we have this opportunity today. Before diving into Leaf-specific activities, I would like to step back a little bit and look at the foundation that makes it all possible, which is Lesaffre. Lesaffre is by itself living organism with more than 170 years of experience in fermentation and biotechnology. Now, over a century and a half, we've grown by staying true to the same values that define our foundations, which are innovation, collaboration, and respect for life. Today, Lesaffre owns over 11,000 employees across 80 manufacturing sites in more than 180 countries, generating more than 3 billion euros in turnover. Our expertise covers every aspect of fermentation, from baking and nutrition to health, biotech, and renewable energy. This breadth of experience gives us a truly unique position in understanding microorganisms and using them to benefit people and the planet. Every day, our teams from research centers to production plants work together to explore and reveal the infinite potential of microorganisms. But now, as we all know, the world is facing a lot of challenges for nourishing nearly 9 billion people by 2050. So our mission at Lesaffre remains very clear: to better nourish and protect the planet through the power of fermentation. This is the foundation upon which Leaf was built, and it's what continues to inspire our vision for the future. Next slide, please. Now, I've been speaking about Lesaffre. Let's look at how this long-standing expertise comes into life across our different fields of activities. As you see here in this slide, the DNA remains deeply rooted into our core business, which is fermentation. What you see here is the Lesaffre ecosystem, a network of specialized business units, each one dedicated to unlocking the potential of microorganisms in very specific market. Through its diversity, Lesaffre addresses multiple sectors. For example, the baking sector. We offer a full range of baking solutions, from yeast and sourdoughs to improver and mixes, serving both craft and industrial bakers across all manufacturing processes. Health and nutrition then. IDEO, a business unit, enhances animal health through microbiota and immunity management. Another business unit called Gnosis develops nutritional actives and probiotics benefiting human health and well-being. And the business, Agroxin, advances sustainable agricultural through biocontrol, biostimulation, and bionutrition. The last sector, well, not the last actually, food, taste, and pleasure. BioSpringer is the business unit that produces natural yeast ingredients for taste and flavor. Enolis is the business unit in the group that uses biotechnology to create natural flavor molecules for food, fragrance, and nutrition. And Fermentis brings fermentation expertise to brewers, winemakers, and distillers all around the world. Then the last sector is industrial biotechnology. This provides spray drying services for ingredient producers. Procelis supplies nutrients and expertise to boost microbial and cell culture productivity. And Leaf develops fermentation solutions enabling industrial manufacturers to lower their environmental footprint. Together, these branches make up a single interconnected vision to harness the power of microorganisms to better nourish, protect, and preserve the planet. And this is where Leaf comes. Leaf stands at the crossroads between Lesaffre's 170 years of fermentation expertise and the growing demand for sustainable industrial solutions. Our purpose at Leaf is very clear. We are your industrial fermentation partner for a sustainable tomorrow. Just like the bridge you see in the previous image, Leaf connects science and industry, nature and innovation, and ultimately today's challenges with tomorrow's opportunities. We work hand in hand with bio-based industries around the world, from renewable fuels and biochemicals to emerging bio-based materials, in order to help them replace fossil-based solutions with biological ones. Our mission is to make industrial fermentation a driver for sustainability. Next slide, please. At Leaf, our strength lies in the combination of two words. On one side, the scientific and industrial power of the group Lesaffre, and on the other side, the deep process knowledge of bio-based industries. On one side, we built on Lesaffre's industrial and technical expertise, decades of experience in yeast production, microbial science, and large-scale fermentation. This offers Leaf a strong foundation of reliability, quality, and innovation capacity. On the other side, we bring application expertise, understanding how microorganisms behave in real industrial environments under conditions faced by ethanol producers. By connecting these two words, we are able to provide concrete, data-driven solutions that answer our clients' challenges, improving efficiency, yield, and sustainability. In short, Leaf transforms Lesaffre fermentation excellence into industrial performance and environmental impact reduction for our partners. Now, I've been speaking about innovation, and it was the topic of the day. At Leaf, one of our key missions is to innovate for ethanol industry, an industry at the very heart of a global bioeconomy. Ethanol today is more than just renewable fuel. According to us, it's a cornerstone of a transition toward a low-carbon future and a gateway to multiple bio-based opportunities. Over the years, we've built a deep understanding of ethanol production, working side by side with you, our partners, from starch-based to cane-based producers in order to improve yields, reduce costs, and make operations more sustainable. Our innovation combines scientific expertise, but also digital intelligence and field experience in order to ensure that every fermentation step, from yeast performance to process optimization, can create measurable value. Next slide, please.
Yes.
At Leaf, we believe that the next era of industrial fermentation requires a complete new way of thinking. The challenges our partners are facing today and those that lie ahead are becoming increasingly complex. And you know that very well in India. Feedstock quality varies, plant configuration evolve, and production expectations always continue to rise to generate more margins. That's why we developed the concept of CP square, a comprehensive coupled product and process. Comprehensive means we take a holistic view, understanding that performance depends not only on the yeast itself, but also on the process environment, operational practices, and data interpretation. And coupled means we treat the product and the process as one living system. At least we know that the interaction between the two is where the true optimization happens and where we can unlock new level of performance and sustainability. We believe that creating value for our partners goes far beyond supplying just a yeast strain. True performance comes from how product, process, and people work together. And that's exactly what our technical service platform is built for. Our approach is structured and comprehensive. We call it our A to F framework, representing the 6 pillars of Leaf technical service available today. A, training. We empower our partners' teams, whether it's operators, engineers, managers, through practical and scientific training on fermentation, yeast nutrition, and process optimization. Some of you have already participated to what we call Leaf fermentation workshops, but also Leaf yeast days. B, data mining. What means data mining? We analyze the production data in detail to identify trends and areas for improvement. This is where the expertise in our technical team converts the analysis of the data into tracks for improvements for better profitability. C, optimization. We work side by side with our partners to fine-tune the key parameters from temperature and pH to propagation and yeast management in order to achieve best performances. And that goes beyond just temperature and pH. We can understand the levels of osmotic pressure in order to optimize in the best way the hydrolysis to give best opportunities for the yeast to convert all available sugars. D, troubleshooting. When challenges arise, we should not just react. We help diagnosing the problems and as much as possible preventing the problem, but also we solve it with corrective actions and preventing issues. E, microbial audit. We can monitor contamination control and hygiene practices in order to protect the consistency and stability of our customers' fermentations. All the members present in this room know how difficult it is once the contamination has already spread into the fermentation and that there is nothing much you can do to fight against these bacteria that are already present. F, advanced services. We provide tailor-made in-depth projects and audit for specific industrial challenges requiring deeper technical insight. Altogether, these 6 pillars form the backbone of how Leaf Technical Services create measurable and sustainable value for ethanol producers. But as the industry evolves, so the challenges. That's why our service model is not static. It continuously innovates. And today we are speaking about innovation. And when we hear about innovation, well, we think about product innovation, which will be presented later on into this speech. But we should also think about technical service innovation and to share how Leaf is bringing technology, connectivity, and data science into a global technical service toolbox. I will now hand over to Furqan, who will take us through the next generation of innovative service solutions that are transforming the way we support our partners in India. Thank you very much.
Thank you, Chris, for sharing the insights about Leaf and how we are working together with ethanol producer to create value through technical services. I hope I'm audible to the participants, and namaste सभी को
Yes,
मेरा
sir,
नमस्ते.
you are audible. Namaste.
नमस्ते जो भी पार्टिसिपेट कर रहे हैं हमारे इस वेबिनार में, and thank you GEMA for providing this opportunity to share our experience. My name is Furqan Ali, working as a technical service representative in India for Leaf. As Chris was mentioning about the innovation and how crucial it is for the ethanol manufacturer, we truly believe in innovation, and that not just at the level of product, but also innovation at the level of services. In order to create value, we must go a step further by integrating our services together with the products. Hence, our endeavor to bring innovation to the services along with the traditional technical services. So my emphasis would be in these sections to share how Leaf is committed towards innovation in services. Next slide, please. Chris has briefly mentioned as how ethanol industry is becoming more and more challenging, and to overcome this challenge, one of the main important bottleneck and criteria is industrial profitability. Profitability is necessity for any industry, and ethanol industry is no exception. Therefore, it is our commitment to maximize our customer profitability by having the innovative ways of working by integrating services and the product. Noise is not clear. I see the message. Is it for everyone or सब सुन पा रहे हैं मुझे या सुनने में दिक्कत है?
You are audible.
We are audible.
Okay, so sorry, I saw the message. Sorry.
You are audible, sir.
ओके थैंक यू सो हमें इनोवेशन क्यों चाहिए टेक सर्विसेज में सबसे एक बड़ा क्वेश्चन आता है हर एक काम करने से पहले व्हाई डू वी नीड इनोवेशन इन सर्विसेज ड्यूरिंग आवर प्लांट विजिट वी नोटिस एटलीस्ट इन इंडिया द डेटा इज बीइंग ऑफन कलेक्टेड मैनुअली जहां पे भी मैंने विजिट किया है मोस्टली प्लांट में जो प्रोसेस पैरामीटर है एंड जो लैब डेटा है वो लॉग बुक में एंटर होता है एंड उसके बाद में वो डेटा यूज होके इंफॉर्मेशन बनता है एंड देन इट टेक्स टू द डिसीजन मेकिंग प्रोसेस which is very that slows down a lot and that happens because of many reasons. अब इसमें हम क्या कर सकते हैं इनोवेटिव तरीके से उस पे हम बात करेंगे इसके एडिशन में रिमोट मॉनिटरिंग एंड ऑटोमेशन आर स्टिल लिमिटेड इसमें हम क्या देखते हैं कि अभी इंडियन मैन्युफैक्चरर जो इथेनॉल प्रोड्यूसर्स है वहां पे जो रिमोट मॉनिटरिंग है कि मैं घर पे बैठ के अपने प्लांट को मॉनिटर कर सकूं या मेजर ऑटोमेशन इंस्ट्रूमेंटेशन हमारे इथेनॉल प्लांट में नहीं है क्या हम इस प्रोएक्टिव अप्रोच को जो हमारा जैसे कुछ प्रॉब्लम आ जाता है तो उसको प्रोएक्टिव में कन्वर्ट कर सकते हैं ये एक बड़ा क्वेश्चन है जो हम अपने आप से भी पूछते हैं और इथेनॉल प्रोड्यूसर के साथ में भी पूछते हैं नेक्स्ट स्लाइड प्लीज अगर मुझे एज ए टेक्निकल एक्सपर्ट एज ए फर्मेंटेशन साइंटिस्ट मुझे एक प्लेटफॉर्म मिल जाए व्हाट इफ there was a platform that could automate data collection and deliver near real live insights so that could be something that very innovative very creative but also very useful for the ethanol producer what if this platform protected your data while enabling secure 24 access. क्या ऐसा हो सकता है कि जो हमारा ये डेटा होता है प्लांट में, प्रोसेस डेटा, क्या 24/7 का इसका कलेक्शन हो सेफली एंड मुझे रिमोटली एक्सेस मिल जाए? मुझे मतलब आपके जो प्लांट मैनेजर्स हैं, प्रोडक्शन मैनेजर्स है, वो देख पाए कि हमारा टेम्परेचर क्या है, हमारा बेस्ट टाइम क्या है, ये सारा हम कर सकते हैं क्या? What if instead of simply reacting, we could predict issues, optimize KPI, and improve efficiency ahead of time? So this is something that we believe can change a lot, and it can create value by improving the efficiency. Wouldn't that transform how we approach fermentation and industrial excellence? So in many industries, some of these tools, some of these ideas are being implemented and the efficiency is being improved. But if we could do it this in ethanol industry in India, that could change a lot. Next slide, please. We listened, we developed, and today I am very proud to introduce to you the Fermentation Center of Excellence, FCOE by Leaf. This is something we have been working on quite some time, and this platform, we are again showcasing this as an innovative solutions in services to serve Indian ethanol producers to maximize performances. Next slide, please. How it works, we combine the robust data access from the plant, and we focus on three main KPI operations which are critical for the fermentation operation. First one is liquefaction, second one is a pre-fermentation, and third one is fermentation. And it does not only collect the data or formulate into some kind of report, but also from the leaf point of view, it has a solid industry knowledge, a fermentation knowledge, which Chris has mentioned about our century-old experience in fermentation, which could utilize to build this platform and help serve the Indian ethanol producer. इसमें क्या होता है कि जो हमारा FCOE है, उसके थ्रू हमें रोबोस्ट डेटा एक्सेस मिलता है प्लांट से। हम तीन मेन KPI पे काम करते हैं: लिक्विफैक्शन, प्री फर्मेंटेशन, फर्मेंटेशन, एंड थर्ड वाला जो इम्पोर्टेंट है कि हम जो हमारा लीफ का फर्मेंटेशन एक्सपर्टीज है, उसके साथ में हम काम करते हैं, एंड उसको हम डेटा में इंटीग्रेट करके अपने इंडियन इथेनॉल प्लांट को एक्सेस देते हैं। तो इसका पहला स्टेप है कि डेटा एक्सेस, कैसे डेटा एक्सेस लेते हैं इसका, जो हमारा DCS PLC सिस्टम होता है, वी कनेक्ट इट एंड वी गेट द होल प्रोसेस डेटा and we combine that into a dashboard, which is a very first basis of our FCOE. Could you please go to the next slide? This is something you would see when you have the FCOE deployed at your plant. At your plant, you will have the first page where you will have an overview and a different KPI, liquefaction, pre-fermentation, and fermentation sections where you can optimize the data collection and create the value using this information to improve the plant performances. Addition to that, you will also have to see the CIP system as how efficient and effective it is in your plant. And each and every section you will have the plot where you can access the operations of your plant near live data, and that can be formulated into the report and create a value. Next slide, please. This is not only a digital tool which acquire the data and convert into report, but it is backed by solid industrial knowledge what we have, specifically focusing on the fermentation, that helps to improve and maximize the efficiency of fermentation, therefore plant profitability. Next slide, please. If you see in this picture, the cartoon, where we are at the moment in Indian plant, if you see, if you follow the cursor here, the pointer, the first one is the manual data which is being logged in the books. After FCOE, it will be converted into automatic data collection and near lifetime analysis. And it also has the currently what we are doing a reactive troubleshooting after problem arises, but with the FCOE it will be a proactive approach, which means that a near live data will come and action can be taken to identify this scope of improvement, and then it can be deployed. Limited remote monitoring capability. As I mentioned that in Indian ethanol plants, we have a limited automation, therefore limited remote access of monitoring data. But with the FCOE, you'll have a 24/7 remote access to the fermentation insights. It's not only as how the plant is running, but what more can be done after deploying this FCOE. And that is complemented with the expert-driven performance optimization and strategic guidelines in the program, which helps to improve the efficiency of the plant, thereby plant profitability. Next slide, please. Challenge will continue to come, and for ethanol producer to remain profitable, innovation is necessary. This is what we believe, and FCOE is already creating value by improving efficiency, reducing downtime, and optimizing KPIs here in India. But this is just the beginning. Next step is, as always, trying to further improve and advance this platform that actively supports decision and drives sustainable profitability. Which I mentioned that FCOE by Leaf is a key enabler for industrial processes, excellence, and sustainable profitability. So this is what we believe, and we are committed to create value by innovating in services and deploying this at the Indian ethanol producers. Next slide, please. So this section was dedicated more towards the advanced fermentation technical services which Leaf is offering. And the second component is the innovation in product. We Leaf believe not only limited to the services and the product, but the combination of two, as Chris also discussed, CP2, CP square. There has been a lot of talks about GMO, how GMO is effective, genetically modified organism. Once the regulatory hurdles have been cleared, but we understand non-GMO solutions are extremely important for ethanol producers all over the world. Leaf has listened and come up with the innovation for non-GMO solutions. So this section I'll be discussing about नॉन जीएमओ, जो जीएमओ नहीं होते हैं, जैसे अभी हमारा जो भी सॉल्यूशंस है मार्केट में इंडिया में यूज होता है, सेम वैसा ही जीएमओ होता है जिसमें जेनेटिकली मॉडिफाइड होता है और डिफरेंट रेगुलेशंस यूज करने होते हैं उसको पहले इंपोर्ट करने के लिए, फिर उसको प्रोडक्ट को यूज करने के लिए. डॉक्टर सिबा विल टेक दैट सेक्शन. So I'll be discussing innovation in non-GMO segment. जैसे मैंने बताया कि लीफ जो है वो कमिटेड है इनोवेशंस के लिए, एंड we are the yeast manufacturer, and this is the one step where we can create value, and value where we can see improvement in any of the KPI which can add on any profit to the plant is something we like to continue. What is this technique we are discussing? Strain hybridization technique is the key strategy in developing robust high performance strain for industrial ethanol production by combining desirable traits from different parent strain. अगर आप इस स्लाइड में देखेंगे लेफ्ट हैंड साइड में ईस्ट का एक फोटो लगा है हाई इथेनॉल टॉलरेंस वाला, दूसरा हाई ऑस्मोटिक टॉलरेंस वाला। अगर ये ईस्ट का जो हाइब्रिडाइजेशन टेक्निक होती है इसको इन विट्रो टेक्निक में बोलते हैं, इन दोनों को हम कंबाइन कर सकते हैं और दो या दो से ज्यादा ऐसा प्रॉपर्टी इंटीग्रेट करके उसको एक नया हाइब्रिड तैयार कर सकते हैं जिसके पास दोनों प्रॉपर्टी होगा। So which means that it will carry the trait of both the mother strains, and then strain will be more robust than its original strain. तो ये ऐसे नहीं होता है कि दो को मिलाया, it takes like 1,000 and sometimes 10,000s of trials where you will have one hybrid which is stable and carry the property of both. तो इसको हम ईस्ट हाइब्रिडाइजेशन टेक्नोलॉजी बोलते हैं। इस पे हमने काम किया, ये हमारा पाइपलाइन है। नेक्स्ट स्लाइड प्लीज। तो इसमें आप देखेंगे कि जो ईस्ट स्ट्रेन सिलेक्शन है दैट इज बेस्ड ऑन केपीआई। केपीआई क्या होता है? प्रोडक्टिविटी, कितना हाई इथेनॉल टाइटर हो सकता है। ईल्ड, सेम ग्रेन से, सेम टन्स ऑफ ग्रेन से कितना ज्यादा इथेनॉल प्रोड्यूस कर सकते हैं। इथेनॉल का टॉलरेंस कितना ज्यादा होता है, टेम्परेचर टॉलरेंस कितना ज्यादा होता है, बाकी जो नॉन एसिडिक एसिड टॉलरेंस है, बाकी सारे जितने भी स्ट्रेसेस है इंडस्ट्रियल लेवल पे, उसको कंबाइन करके स्ट्रेस से हम बनाते हैं। जो हमारा स्ट्रेटजी है, जो आप इसमें देखेंगे लेफ्ट हैंड साइड में हाइब्रिड्स, वो हाइब्रिड्स जब हम उसको टेस्ट करते हैं तो न्यू हाइब्रिड में वो प्रॉपर्टी होना चाहिए, दैट इज द प्रोडक्ट, द स्ट्रेन कम्स आउट एज ए कमर्शियल प्रोडक्ट। तो ये हमारा बैकग्राउंड है इस टेक्नोलॉजी के पीछे, इसको कैसे इंप्रूव करते हैं। सो दिस इज नॉट समथिंग दैट comes directly from the environment and you have ready and you can use it. So it takes years and years together of innovation to come with the new product which is better than the traditional or conventional product what we have in already in the market as a benchmark. Next slide please. So I'm very happy to announce this platform of hybridized yeast, which we call is Virtue. So I'm very proud to be part of this introduction, which we call as a pathway to progress. अगर आप देखेंगे इसमें ये Virtue हमारा एक platform है, and in Virtue you have a different levels of innovations and benefits which is combined not only with the product but also the services. जैसे आपने पीछे देखा कि हमारे पास ट्रेडिशनल सर्विस है, हमारे पास एडवांस फर्मेंटेशन सर्विसेज है which is part of the FCOE. तो जो हमारा ये वर्च्यू प्लेटफॉर्म शुरू होता है वर्च्यू एक्सेस से, देन वर्च्यू कोर एंड देन द वर्च्यू एज, इस पे हम बात करेंगे एंड बियॉन्ड। सो हमारा ये प्लेटफॉर्म है, इट्स इवॉल्विंग एंड इनोवेटिंग every day, and this is our ambition that we will have a one step above than the previous one, and these products and solutions are not only the e-solutions, it is combined with the whole package. So you will hear more about each of these solutions in coming future. I'll be discussing one of example in here in this platform. Next slide please. सो मैं इस प्लेटफॉर्म पे वर्च्यू एच को शोकेस करना चाहूंगा, दैट ब्रिंगिंग रियल प्रोग्रेस टू मोस्ट ऑफ द क्रिटिकल प्रायोरिटीज, बिकॉज developing benchmark product better than the benchmark product is something we have ambition. So इसमें हमारा main specific objective and key properties क्या है? Lower your operational cost, इससे energy save होता है। थ्रू हायर केपीआईज, वो क्या होते हैं? प्रोडक्टिविटी, यील्ड एंड इथेनॉल टाइटर। अगर हम इस पे करेंगे देन इट इम्प्रूव्स द प्लांट परफॉर्मेंस, देयर बाय प्लांट प्रॉफिटेबिलिटी। मिटिगेट स्ट्रेस, जैसे हमें पता है कि इंडिया में नॉर्थ से साउथ तक अलग अलग इन्वायरमेंट होता है, टेम्परेचर से लेके कोल्ड, हर एक टाइम पे अलग स्ट्रेसेस होते हैं थ्रू आउट द ईयर। ग्रेन चेंज होता है, वाटर चेंज होता है, तो उन सारे स्ट्रेस को मिटिगेट कर पाए, इंक्रीज योर ओवरऑल प्रॉफिटेबिलिटी। अल्टीमेट गोल क्या है इनोवेशन का? कि आपको प्रॉफिटेबिलिटी, इट शुड इम्प्रूव plant profitability by adding or advancing one of the KPI or all the KPI. So this is one of the objective of the innovation. Next slide, please. So ये हमने जो वर्चू एज है, उसको हमने जो इंडियन राइस है उस पे टेस्ट किया है लैब स्केल पे, और इंडियन प्लांट से मैश लेके भी, और जो राइस है उसका मैश लैब में बना के। तो अगर आप देखेंगे जो हमारा बेंचमार्क है इथेनॉल रेट, उसके कंपेयर में अगर आप देखेंगे तो इसमें 1.4% का यील्ड गेन है बाय कीपिंग सेम डीएस, सेम स्टार्च कंटेंट। तो ये यील्ड गेन 1.4% का है। दैट इज वन ऑफ द केपीआई वी वर वर्किंग ऑन वर्चू एज। इट हैज अ लॉट, बट आई एम जस्ट डिस्कसिंग वन ऑफ द प्रॉपर्टी इन हियर। वो कहाँ से आता है, ये भी इंपॉर्टेंट क्वेश्चन है कि कई बार यील्ड गेन दिखा देते हैं, बट उसमें वो पता लगाना है कि कहाँ से आया है, बिकॉज इट इज थ्रू साइंटिफिक मेथड, एंड द साइंटिफिक मेथड हैज टू हैव द राइट आंसर। तो अगर आप देखेंगे इसमें राइट हैंड साइड पे, इफ यू फॉलो द कर्सर पॉइंटर, एचपीएलसी शुगर एंड बाई प्रोडक्ट प्रोफाइल में, तो इसमें 15% से ज्यादा ग्लिसरॉल रिडक्शन होता है इन द सेम कंडीशन के चेंज करे बगैर, एंड देर इज अ डिफरेंस इन द शुगर प्रोफाइलिंग एज वेल। तो वहां से इसको इथेनॉल निकल के आता है, एंड दिस 1.54% यील्ड गेन इज क्वाइट सिग्निफिकेंट। अगर हम नेक्स्ट स्लाइड पे जाएंगे तो देखेंगे कि इसका इम्पैक्ट प्लांट प्रॉफिटेबिलिटी पे कैसे बनता है, क्योंकि आपने देखा होगा कि मैं शुरू से वही बात कर रहा हूँ कि प्रॉफिटेबिलिटी एंड इनोवेशन जो भी हम करते हैं वो प्रॉफिटेबिलिटी में कैसे कन्वर्ट होता है। तो अगर आप एक 200 के एलपीडी प्लांट का एग्जांपल यहाँ पे लेते हैं, ये एस्टिमेटेड यील्ड गेन है। तो राइट हैंड साइड पे अगर आप देखेंगे डेली इथेनॉल यील्ड गेन में, तो इसका अप्रोक्सीमेटली 2940 लीटर इथेनॉल गेन होता है पर डे बाय यूजिंग वर्च्यू एच, जस्ट वर्च्यू एच। सो दिस इज समथिंग क्वाइट सिग्निफिकेंट, 2940 लीटर। अगर आप इसको कन्वर्ट करते हैं एनुअल गेन में, तो एनुअल गेन में 1 मिलियन 10 लाख लीटर इथेनॉल के आसपास आपका गेन होता है वर्च्यू एच से कंपेयर टू बेंचमार्क। अगर आप इसको वैल्यू में कन्वर्ट करते हैं तो दिस इज अप्रोक्सीमेटली 7.09 करोड़ रुपीस एनुअल गेन। सो दिस इज इन estimated benefits you would receive if you have the virtue edge as one of these solution. Next slide please. सो अगर नटशेल में हम देखेंगे कि जो हमारा आज का टॉपिक है इस वेबिनार का, हाउ टू मैक्सिमाइज एफिशिएंसी एंड ऑफ योर प्लांट, एंड दैट इज लेड बाय द यील्ड। वर्च्यू एज इंक्रीजेस 1.4% of ethanol yield by reducing glycerol production by 14.6%, approximately 15%, and other sugars. It targets higher solids, बहुत हाई इथेनॉल तक जाता है। इंडिया में इथेनॉल हम 15-16% करते हैं, बट इसके ऊपर भी हमने टेस्ट किया, इट वर्क्स वेरी नाइस। डिक्रीज एनर्जी कॉस्ट बाय हायर इथेनॉल टाइटल, आपका एनर्जी कॉस्ट घट जाता है अगर हाई डीएस पे काम करते हैं, और प्लांट अगर हाई डीएस चला सकता है तो। एंड इट ऑल्सो हैव अ हायर इथेनॉल टॉलरेंस, देयर बाय हायर प्रोडक्टिविटी। सो इट हैज lot of tremendous opportunity to work with at the plant level. Therefore, it can maximize your performances. So on this note, I'd like to thank GEMA and all the participants in this webinar, and hand it over to Dr. Sibabrata, who will share more about our pipeline and innovation, how we are working at Leaf. Thank you.
Okay, thank you, Dr. Furqan and Christophe. Very good evening. Chitrika, just give me a cue whether I'm audible or not.
Yes, you're audible.
Wonderful. So I can see there are more than 90 people here in this platform. Namaskar, everyone. Shubh Sandhya aapko. So after Furqan and Mr. Chris took you through our some of our innovations about our company, this is now my part, and I would like to just start this evening with a small story from Africa. It was in 1970, 1980 in Africa, especially in the eastern and the west and central part of the Africa. People used to, especially the farmer, used to having a huge problem because of their grain storage issues. They did not have any good ways to store their grain for a long time for future usage. Normally, their major grain is cowpea. Black cowpea used to be their major grain, and it used to be spoiled by different pests during the storage, more than 30%. Some questions are coming, I guess. We can take it at the end of the discussion. So please keep a note, Chitrika.
Yes.
We will take the questions end of the presentation. तो मैं ये कह रहा था, during 70s 80s African people, especially in the central and the western part, suffering from the storage of their grain, and 30% was and more than 30% they used to lose because of the infection from the grain pests. So इस ये जो कंडीशन था, इस कंडीशन का जो हाल होता था, जो फार्मर था उनको कम दाम में अपना जो ग्रेन है वो एक ही टाइम में बेच देना पड़ता था मार्केट में, and when they need it again during the off season, they had to buy it on a double price. दुगनी दाम देके उनको खरीदना पड़ता था जब उनको घर का खाने के लिए ये चाहिए होता था. So it was the condition seen by United States Agency for International Development Board. They are called USAID, and they intervened into this in 1986. 1986 is a memorable year. You may all remember in this year, Maradona from Argentina got the World Cup football. So anyway, in 1986, they intervened, this USAID intervened, and they collaborate with a university called Purdue University. And they selected one of the professors who is an entomologist by profession, Dr. Larry Murdoch from Purdue University, and sent him to Cameroon. Cameroon was in the West and Central Africa, where they were having this problem. And जब ये प्रोफेसर उधर गया, वहां पे जाके इन्होंने विटनेस किया कि कितना सारा वेस्टेज इनका होता है, फार्मर का कितना सारा पेन है, just because of the storage issue. And then he went back to and worked with his research team in Purdue University and developed a special kind of a bag. एक गनी बैग जैसा होता है, बोरी जैसा होता है, तो वैसा एक बैग डेवलप किया ये लोगों ने. और ये बैग का क्या प्रिंसिपल था? They wanted to make the bag in such a way, it was a triple layered bag, and it can cut up oxygen and moisture. अगर आप ऑक्सीजन एंड मॉइस्चर को कट कर देते हो, इन दैट केस कोई पेस्ट या मोल्ड उसमें जी नहीं पाएगा. So it was a simple principle they have applied here in order to develop this bag, and this bag was known for PICS bag, PICS. PICS stands for Purdue Improved Crop Storage Bags. So in short, PICS bag. And using these bags, the African farmers who are struggling to store their grain, they got a wonderful storage and a lifetime of the grains, and they can store it for months for future usage. As a result of that, we have seen that almost 1.75 million PICS bags were sold over 31,000 villages across West and Central Africa during that time. By 2023, just 2 years back, the project had received 11.4 million US dollar internationally. So you can understand the innovation is a mother of necessity. Here, in order to store their cowpea, grain, and corn as well, it was a necessity for them, and it pushed the innovation. And Purdue University come up with the PICS bag with a simple idea, and it worked. It was made by polyethylene and polypropylene, and give this hermetic nature of this, and successfully they come up with the PICS bag. So why I'm saying this story? Because in the context of Indian ethanol industry, if you can just change the slide, Chitrika, today what we can see after, can you please change the slide, Chitrika? Wonderful. So just to go on, after a skyrocket growth in Indian grain ethanol capacity, in the last 3-4 years, the industry strives to be sustainably profitable for years to come. The equation of profitability depends today on several factors. Please click one by one and finish the clicking of this slide, Chitrika. Here, I will take some of them which we can technically tackle together starting today. So these are something जो हम लोग आज ही चालू कर सकते हैं together मिलके. So what are these things? So when an efficient grain management is one of them. आज के scenario में, when we see the allocation, especially for the dedicated plants who are the producers grain for fuel ethanol, and we have seen that the allocation is not everywhere the same. So, and we have seen that government is releasing the FCI rice, and there is a mandate of usage of 40% for the next 3 quarters. Then from June, they will stop giving, I think, FCI rice. We have to then depend 100% on the maize as well as on the DFG. So there is a scenario come up when it is absolutely necessary that we need to have a smart grain management. Procuring grains during the peak season and providing proper storage for longer period would dodge higher raw material price during the off season. On the other hand, byproduct valorization, a point to focus on due to drastic reduction of the DDGS price, which was a result from the surge of supply, right? DDGS का दाम कम हो गया, supply बढ़ गया, which is a natural equation. Now, from the technical point of view, if we put improvement of the fermentation KPI, Dr. Furqan just now told about the fermentation KPIs for the ethanol producers, which includes ethanol recovery per unit of grain, ethanol productivity per hour, and the energy savings in the process. These remain on the top of our list for maximizing profitability. So we at Leaf are committed to the continuous improvement of our product and services, offer through continuous innovation to unlock maximum value in process for our partners while paving the route of net zero, because we believe on the sustainable development. So Dr. Furqan took you through the Leaf innovations in the segment of non-genetically modified yeast, non-GMO in short. Here I will speak about some genetically modified or genetically engineered or GMO yeast developed by Leaf for the fuel ethanol makers. Next slide, please. For GM yeast, Leaf has developed an entire platform and we name it Evolve. So Evolve is not only the yeast name or the technology name, it's the name of a platform. This platform reflects our passion for innovation, which is more than a yeast range. It is the result of 170 years of fermentation experience and the revolution where technical expertise meets cutting-edge science. Offering high-performance yeast products specifically designed for fuel ethanol production, we strongly believe that Evolve platform is the future for fuel ethanol fermentation. Leaf's industrial fermentation experts and Green Lab team, which is based in US Cedar Rapids, combined with their skills with the Lesaffre Institute of Science and Technology and Recombia Biosciences to develop this Evolve. So these are the minds, these are the bright minds, these are the brains, these are the scientists who are involved in order to develop this Evolve platform, which is grounded in science and fueled by innovation. So what is the result of this platform? We will get into the product name with this, and the product name is Evolve Evergreen, our advanced yeast product for the Evolve from the Evolve platform for 1G ethanol production. Ladies and gentlemen, we are already having a GM product for 2G ethanol, which is called Silax. And Silax have different varieties or versions. I'm not getting into that. So here, just to differentiate, this is the GMO product, and this is GMO product for 1G ethanol, and the name of the product is Evolve Evergreen, from where it is coming from the platform Evolve. Is it GMO? Yes, it is a GMO. yeast product for 1G ethanol production. Evolve Evergreen was specifically developed to face today's and future ethanol production challenges, keeping sustainability as the core. In short, this solution is to maximizing efficiency and yields while minimizing costs and environmental footprint. Evolved Evergreen is highly performant Saccharomyces cerevisiae yeast with high robustness coming from its skeleton from the popular ethanol red. Most of you are already seen and realize the performance of the ethanol red, know about the robustness of the ethanol red. So that the skeleton of the ethanol red has been taken and used to develop this special yeast in a genetically modified and engineering way. Its reliability, even under a wide range of temperature, high temperature like 40 degrees Celsius, allows us, our partner, to perform consistent fermentations and to sustain plant performances by limiting day-to-day disruption. It's a very, very important part because we have seen जब हम लोग plant में जाते हैं, day-to-day disruption is reflecting on the data standard deviation. In statistics, we call it standard deviation. Production अभी 0.5% ऊंचा हुआ, production कभी 0.5% नीचे गया. ये जो ऊपर नीच होता है, this is called the standard deviation. तो ये ऊपर नीच होने के लिए बहुत सारा कारण होता है. If my process and if my product is robust enough and optimized enough, then this standard deviation will be reduced with the time. And this is a strong indication your process is smooth and your losses are reduced. Through its enhanced metabolic capabilities of this evolved evergreen glucoamylase, जो enzyme आप लोग fermenter में डालते हो, the GA or glucoamylase, this yeast can produce by itself. Okay, so, and with the amount it producing, we can replace around 50% of exogenous GA. जो jerrycan से आप लोग डालते हो, वो jerrycan 50% आप कम कर सकते हो because this yeast will itself produce 50% for you. And not only that, this is most importantly will reduce the byproduct formation, which is glycerol, is one of the most I should say costly byproduct from the point of view of the loss. When you are making 2% of glycerol in your fermenter, that means it has eaten around 2% of your sugar, which is relatively costlier than everything. So if you can reduce the glycerol, which is naturally produced by the yeast in its metabolic pathway, this system or this yeast has been specially designed to reduce the glycerol production and channelize most of the sugar to produce ethanol. And in that way, it is reduced around 49% of glycerol production during the fermentation, which is giving you the benefit of yield up to 2%. So now come to the plant result. Here you can see in the slide, it is a plant data. And what we are trying to see here, yeast यहाँ पे खुद GA बनाते हैं और ये जो feature है GA बनाने का, it is giving a different power to the system. We have seen a lot of time because of high osmotic stress, which is coming because of the high sugar concentration, more than 8%, more than 9%. Sometimes we have seen during the filling period, the concentration of the RS going beyond 10%. Okay, so this is the concentration where the condition is osmotically stressed for a yeast. As in this particular organism, evolved evergreen, it itself producing GA, so it can have an upper hand to manage this sugar surge. ये खुद manage कर सकता है अपने आप, as it is also producing GA, कि इसको कितना GA, कितना sugar चाहिए, and accordingly it is producing the GA in order to reduce or limit the stress from the osmotic pressure. और यहाँ पे क्या हो रहा है, ईस्ट ज्यादा इथेनॉल बना रहा है. इट्स अ स्ट्रेट फॉरवर्ड कार्बन बैलेंस, जितना कार्बन जा रहा है उससे मैक्सिमम जो है वो बन रहा है अल्कोहल.
Siba?
Yeah, someone muted me. It seems like they do not want to listen to me. Is that the case? No, right? Can I continue?
Yes, sir. Please
Yes,
continue.
please.
You are audible, sir.
सो मैं ये बोल रहा था, ये जो ईस्ट है आप इधर देख सकते हो, इसका 49% ग्लिसरॉल मतलब बाई प्रोडक्ट फॉर्मेशन जो है वो कम होता है, जो आपका सेम इनपुट ऑफ ग्लूकोज से बनता था। और उसके लिए क्या हो रहा है, इसका इथेनॉल जो है वो ज्यादा मात्रा में बन रहा है, +2% आपका यील्ड इंप्रूवमेंट हो रहा है। इसका मतलब क्या है, हो रहा है आपका ग्लिसरॉल जो है वो कम जा रहा है आपका डीडीजीएस में, राइट? एज सिंपल एज दैट। सो जितना कम आपका डीडीजीएस में ग्लिसरॉल जाएगा, डीडीजीएस का क्वालिटी के लिए ये उतना अच्छा है। एंड एट द सेम टाइम जब शुगर आपका मैक्सिमम एफिशिएंसी में यूटिलाइज होके इथेनॉल बन रहा है, आपका कार्बन डाइऑक्साइड भी ज्यादा बन रहा है, तो इट विल पुश योर कार्बन डाइऑक्साइड प्रोडक्शन along with the ethanol production. At the same time, it will concentrate, give a relative concentration increase of protein in your DDGS. ठीक है, ज्यादा शुगर अगर कन्वर्ट होके गैस हो गया और अल्कोहल होके निकल गया, तो बाकी जो रह जाएगा उसमें प्रोटीन का एक रिलेटिव कॉन्सेंट्रेशन इंक्रीज होगा। सो द DDGS you can expect from this strain will be more richer in protein and the trace elements like vitamin and other metal ions which are good for animal health. Next slide, please. Let us see how it looks in the plant. If you just look into the graph or the cartoon I made here in the presentation, the upside in the blue highlight is the normal non-GM yeast, ethanol red in this case for your example, and the bottom part highlighted in the yellow is evergreen, which is a GM yeast having some special properties. So now if I get into the left side, extreme left side, where I have shown the grain. So you have a limited grain per batch. Maybe it is maize, maybe it is rice. Then you are doing a liquefaction under temperature, sometimes with pressure or sometimes without pressure. And you are using jerry cans of enzyme. So like alpha amylase. So you are, adding maybe 0.1 or 0.2 kg per starch in or 0.5 kg per starch, depending on your enzyme suppliers advice. So in order to liquefy the mash, right? In order to liquefy the mash. So this process is the same in both cases. Let me now just recapitulate how it is processed further. अगर ऊपर वाला हिस्सा में हम लोग देखते हैं, यू कैन सी देयर आर 4 कैन्स ऑफ जीए। तो ये प्रोसेस के लिए फॉर एग्जांपल हम लोगों को 4 कैन लगता है जीए का, 4 जेरी कैन लगता है जीए का, ये फर्मेंटर में प्रोसेस के लिए। जीए आपने डाल दिया फर्मेंटर में और धीरे धीरे आपका जो स्टार्च है वो डेक्सट्रीन होगा, डेक्सट्रीन से धीरे धीरे काट काट के वो ग्लूकोज में कन्वर्ट हो जाएगा। ये जो पीला ड्रॉप मैंने दिखाया है, this is nothing but the glucose. Just imagine, don't get into the numbers, how many numbers are there, how many moles are there. It is just to give you some inspiration. तो जब ये फर्मेंटेशन होगा, ये ग्लूकोज को ईस्ट कन्वर्ट करेगा इथेनॉल में, कार्बन डाइऑक्साइड में, उसके साथ ग्लिसरॉल बनेगा, उसके साथ बायोमास बनेगा, उसके साथ एसिटिक एसिड बनेगा, उसके साथ फ्यूजल ऑयल लाइक हायर अल्कोहल्स बनेगा। यहाँ पे मैंने ये कंसीडर नहीं किया है कि यहाँ पे कोई कंटामिनेशन नहीं है। अगर कंटामिनेशन होता है तो बहुत सारा शुगर आपका डिफरेंट ऑर्गेनिक एसिड्स फॉर एग्जांपल लैक्टिक एसिड में भी कन्वर्ट हो जाता है। तो यहाँ पे मैंने सोच लिया कि लैक्टिक एसिड बैक्टीरिया का कोई कंटामिनेशन नहीं है या दूसरा बैक्टीरिया का कोई कंटामिनेशन नहीं है। अगर सिर्फ ईस्ट मेरा शुगर को खाता है, जो मैंने इनपुट दिया है, वो क्या क्या में कन्वर्ट होता है, तो उससे देखा जाए तो इट मेक्स इथेनॉल एंड कार्बन डाइऑक्साइड प्राइमरीली, उसके साथ बाई प्रोडक्ट में ग्लिसरॉल बनता है, बायोमास खुद ईस्ट खुद को बनाते हैं, उसके लिए शुगर खाते हैं, उसके साथ थोड़ा ऑर्गेनिक एसिड बनते हैं जैसे एसिटिक एसिड, एंड उसके साथ एफओ बनता है डिपेंडिंग ऑन द लेवल ऑफ द स्ट्रेस। नाउ लुकिंग टू द बॉटम फेस, आप यहाँ पे देखिए, यहाँ पे जो जीए का एक्सटर्नल जो हम लोग 4 कैन यूज किए थे ऊपर वाले केस में, यहाँ पे वो कम करके मैंने 2 कैन कर दिया है। मतलब 50% एक्सोजेनस एक्सटर्नली जेरिकैन वाला जो आपका जीए है, ग्लूकोएमाइलेज है, वो कम कर सकते हैं आप अगर आप ये ईस्ट यूज करते हो, क्योंकि 2 कैन के बराबर। अब राइट हैंड साइड में देखिए, ईस्ट से मैंने एक एरो दिखाया है, उधर 2 कैन दिया है मैंने, So it means yeast itself producing equivalent to 50% of GA inside the fermenter during fermentation. And it is helping in the same way for the saccharification. And as a result of that, if you see, there are same product formation, ethanol बना है, glycerol बना है, और वहां पे जो मेरा फेस आ रहा है, that फेस के पीछे वो सेम बाई प्रोडक्ट है. ठीक है, बायोमास है, एसिटिक एसिड है, और फ्यूजल ऑयल है. बट व्हाट इज द डिफरेंस? यहाँ पे जो ग्रीन डॉट्स है, विच इज डिनोटिंग द इथेनॉल, उसका मात्रा बढ़ गया है. ठीक है, और ग्लिसरॉल जो है कम हो गया है. Who are interested in the material balance or the carbon balance? For them, the carbons or the ethanol here is coming because the less glycerol is forming. Okay, so this is the carbon balance for this product. Just in an easy way, I have tried to project it, how it looks in an actual operation. But we will realize when we will get the opportunity to work with you in the plant. With that, we will get into the next slide, where we will discuss about an approach. What is the approach? Today, in order to harness maximum value, हम लोगों को approach में भी we can do something smart, which is already proven. Let me give one example. जो प्लांट में आज हम लोग मक्का यूज करते हैं, in that मक्का we can go up to 32 to 34% of the DS using 100% of the maize, and मेरा इथेनॉल जाता है 12.5 13.5%, लगभग इतना ही. ओके, डिपेंडिंग ऑन द स्टार्च कंटेंट. एक मोटा मोटा फिगर पकड़ लेते. सेम प्लांट में अगर मैं राइस के साथ बनाता हूं अल्कोहल, वो मेरा आराम से 14-15% तक अल्कोहल दे देता है, क्योंकि मेरा डीएस बढ़ाने में कोई प्रॉब्लम नहीं होता है. तो इट इज वेरी मच डुएबल. और यहाँ पे अगर आपका डिस्टिलेशन प्लांट का देखा जाए, उधर भी कोई प्रॉब्लम नहीं होगा, क्योंकि ये आराम से 14-15% अल्कोहल को निचोड़ के निकालते हैं with the help of that distillation system capacity. So now the point is why we should limit ourselves within 13.5% alcohol with maize. So I took this opportunity to write the same thing in LinkedIn also, and I received few comment that why we cannot do it in India. And the comment I have received all are something answering that if I could do this, then it is possible. So the simple thing is, if we can increase the DS, then we can push the production. हम लोग आज DS को बढ़ा नहीं पाते हैं. कभी कभी मिल का कॉन्स्टेंट है, कभी हम लोगों ने देखा है ज्यादा फाइबर के वजह से कुछ मशीन चोक हो जाता है, कभी हम लोगों ने देखा है इसके वजह से आपका जो pH है वो ठीक से काम नहीं करता है. बट दीज आर ऑल इंडिकेटिंग इन अ पॉजिटिव वे. इफ वी कैन rectify or if we can manage these machineries with the help of our engineering partner, we can definitely increase it in order to produce more alcohol. And the concept is called VHG, or the very high gravity fermentation. Okay, so using very high gravity fermentation, where you do not have to improve your capital, or without a huge capital investment, you can actually work on this. And it has relatively significantly high potential to make you profitable. It will reduce your water usage. In today's point of view, who are following the ZLD, it is extremely important. It will reduce your effluent treatment cost. It will reduce your risk of contamination coming from the recycled stream. And it will increase your steam efficiency by concentrating the wash with the ethanol concentration. So ladies and gentlemen, who would like to get into the VHG, especially with 100% maize, we can have a dialogue and we can engage your engineering partner and we can share our insights and we can work together to be more sustainable in this ethanol making process. Next slide. So with this, I would like to wrap it up for the day. Before I finish, I would like to thank you all for your attentive listening and would be available to answer your question if you have any after this. And as a food for your reflection, ladies and gentlemen, would like to share one case study of a pharma company of Spain. Spain का एक pharma company था, okay? and they were using a second-hand liquid chromatography machine for their quality control. And ये लोगों ने देखा कि ये मशीन यूज करते हुए इन लोगों का बैच का काफी प्रॉब्लम हो रहा है, एंड सम इंसिडेंट्स आर हैपनिंग. जो इंसिडेंट्स मतलब है इनका जो प्रोडक्ट है वो छोड़ने में, मतलब क्लियर करने में ज्यादा टाइम ले रहा था. एंड इट वाज कॉस्टिंग अराउंड 100,000 euro per incident. So it was a big loss for them actually. तो मैनेजमेंट क्या किया, इसको रियलाइज किया कि भाई ये मशीन के वजह से मेरा इतना लॉस हो रहा है. ठीक है, मशीन वाज नॉट गिविंग रॉन्ग रिजल्ट, मशीन वाज गिविंग रिजल्ट, दैट्स व्हाई दे कुड मेक बिजनेस एट दैट टाइम. बट जितना एक्यूरेसी चाहिए था उतना नहीं दे रहा था. ओके, सो उन्होंने क्या किया, they planned, they discussed with other instrument suppliers, and they replaced their second-hand LC or liquid chromatography machine with a new HPLC machine. HPLC machine थोड़ा अपग्रेड किया, तो मतलब इंस्ट्रूमेंट को इसने अपग्रेड किया, और उसके बाद क्या रिजल्ट हुआ, the number of incident decreased by 3-fold compared to the older instrument. You got my point, right? Just by upgrading one instrument in the lab, they have reduced their loss by 3-fold. So for our industry, for our very own ethanol industry, to measure precisely the recovery improvement or the energy saving or any essential parameters which is linked to performance, upgradation of more accurate measurement system and instrumentation and digital ways would be helpful in maximizing profitability. Next slide is giving the team of Leaf. So here is our team, Leaf India. We are just a phone call away to work together and to win together. Let us make the nation greener together. Everybody, wish you a very, very good evening. Thank you very much.
Thank you, Siba. Rekha, if it's okay if I go ahead, because I see some of the questions in the chat box.
Can we proceed with the questions over there?
Yeah, I can see a few questions. Sandeep Kumar sir, thank you for your questions. Actually, both questions are from him. So Siba and Furqan, you might take the lead in this. Maximum possible fermentation efficiency in grain fermentation and maximum possible alcohol in fermented wash. So Furqan and Siba, I request you to please answer to sir.
I want to hear the question one more time.
Yeah, so sir's question is maximum possible fermentation efficiency in grain fermentation, and the following
Okay,
question is...
let's park it here and let's answer this one. So thank you for this question. Let's talk about the fermentation efficiency. We're talking about the fermentation efficiency. We have to understand the fermentation efficiency. People have different concept. किसी को लगता है कि मेरा fermenter में sugar खत्म हो जाना ही अच्छा fermentation है, और किसी को लगता है वो शुगर खत्म होके क्या बना, इथेनॉल बना या ग्लिसरॉल बना या लैक्टिक एसिड बना, वो उनके लिए इंपॉर्टेंट. एंड वी आर एक्चुअली बिलीव ऑन दिस सेकेंड बिलीफ. तो जब हम लोग एनालिसिस करते हैं, the way the industry is doing the analysis today, there is a formula of fermentation efficiency. If I just recall that formula to you, so Fe is equals to कितना आटा आपने लिया है, उसमें स्टार्च कितना है, उससे कितना शुगर एंड अल्कोहल बन सकता है, ये आएगा आपका डिनोमिनेटर में, और ऊपर जो आएगा आपका वॉश कितना है, उसमें अल्कोहल कितना बना है. सो आपने क्या लिया, आपने फर्मेंटेशन से अल्कोहल ले लिया कि मेरा 14% या 15% अल्कोहल बना है, मल्टीप्लाइड बाय योर वॉश वॉल्यूम. सो यू आर डायरेक्टली अपफ्रंट कैलकुलेटिंग द अल्कोहल यू मेड, और कहां से आपने बनाया और इससे कितना बनना चाहिए था इज योर डिनोमिनेटर. तो डिनोमिनेटर में हम लोगों ने लिया कि भाई आटा इतना दिया था मैंने, उसमें स्टार्च इतना था और उससे इतना अल्कोहल बनना चाहिए था, taking 51.1% as my theoretical and taking some of the other factors like conversion efficiency. Conversion efficiency means कितना अच्छे से आपका स्टार्च कन्वर्ट होके शुगर हुआ है. ठीक है, So this is important. Sometimes people actually do not care about this, because आपका C अगर ठीक नहीं, या C मतलब conversion efficiency, enzyme conversion efficiency अगर ठीक नहीं हुआ, that will give an impact on the FE or the fermentation efficiency. बहुत सारा जगह पे मैंने देखा है, when you are calculating the FE, they are not considering the CE. I would suggest whenever you are considering to calculate FE, please consider FE as well. If your CE is 95%, then your FE will be much higher. ओके क्योंकि कम आपने शुगर दिया है, वो फटाफट उसको अल्कोहल में फर्मेंट कर दिया है, एंड इट विल गिव यू हायर फिगर. बट व्हेन यू आर गिविंग सी ऑफ 99%, देन देयर इज अ चांस of maybe it is coming in the range of 95-94%. तो नॉर्मली इस पद्धति से हम लोगों ने देखा है कि फर्मेंटेशन एफिशिएंसी ग्रेन के ऊपर 94-95% तक आता है, कभी कभी 96% जाता है, कभी कभी वो 93% भी आ जाता है. तो दिस इज द वन स्कूल ऑफ थॉट प्रोसेस. अनदर स्कूल ऑफ थॉट प्रोसेस कि भाई आपने सैंपल लिया, एचपीएलसी को दे दिया, और एचपीएलसी से आपको ग्लूकोज से क्या क्या बन सकता है सब आपने एक साथ ले लिया, तो आपके पास वाश का पूरा के पूरा अपफ्रंट मटेरियल का एनालिसिस है. उसमें ग्लूकोज कितना बच गया है, स्टार्च कितना बच गया है, आरएसटी का हिसाब आपको मिल गया, उसके साथ ग्लिसरॉल कितना बना है, एसिटिक एसिड कितना बना है, कंटामिनेशन है तो ऑर्गेनिक एसिड लाइक लैक्टिक एसिड कितना बना है, एंड उसके साथ फ्यूजल ऑयल कितना बना है. ये सारा के सारा चीज आपका जो है वो आप डिनोमिनेटर में ले लीजिए, और ऊपर जो है आप अल्कोहल को बिठा दीजिए, और फिर देखिए आपका परसेंटेज कितना आया है. दैट विल गिव अनदर वे कि कार्बन तो यूटिलाइज हुआ है, कार्बन यूटिलाइज होके ग्लूकोज यूटिलाइज होके क्या क्या बना है, this is my scope and this is my alcohol, and that will give you the fermentation efficiency, particularly for ethanol. Okay, and not necessarily जो दो मैंने school of thought process बोला, not necessarily both will be the same. पहला वाला पद्धति से हम लोगों को 94-95 जहां पे मिलता है, इस पद्धति से maybe you will get around 88 to 90%, but both are correct. I will suggest who are doing it, maybe do it different ways, and in both ways, in order to keep the track of their byproduct formation and actual ethanol fermentation efficiency. बहुत ज्यादा मुझे बताना पड़ा because this something is very important for the industry, and it would be give a very good clarity when we will apply this knowledge in our regular practices. Next question, Chitrika.
Yeah, so the next question from Sir was maximum possible. Hello?
Ma'am, you're audible. Please continue.
Yeah, there was some noise, sorry. Maximum possible alcohol in fermented wash.
So maximum, normally we consider ये मतलब इंडिया में जो आता है ऐसा, so taking 95%, 90, Dr. D.K. Singh was saying something. So normally, if you theoretically go by this, if you consider 51.1 gram is your theoretical alcohol, then practically maximum is what is possible around 46 to 47 gram of per gram of per 100 gram of glucose. So the maximum alcohol possibility, to answer your question very precisely, the theoretical answer is 51.1 gram. I am talking about weight by weight, ladies and gentlemen. So 51.1 gram per 100 gram of sugar input. But the practical case, when we are considering the biomass formation, sugar is utilizing for the byproduct formations, then it is not 51.1 gram. It would be around 46 to 47 gram per 100 gram of sugar. Yes.
Maybe one additional comment, Chiki
Yes,
and Siba here, because I can see a lot of interesting questions related to very high gravity and GMO yeast. I would like to, and also a recent one that came about nutrition difference between advanced yeast and non-GMO yeast. It was explained in the slides that we have selected as a host, as a chassis, ethanol red for our GMO solutions. Why have we selected ethanol red? It's because ethanol red is the highest thermotolerant and alcohol tolerant yeast that would keep these properties even if it's becoming a GMO strain. What we do when we call it a GMO is we actually insert a technology by adding DNA or modifying the DNA within the host. So there was one question about what is the higher alcohol we can get? Well, pretty much the same as what you get with ethanol red. There is a question on nutrition. Well, pretty much the same as what you are doing with ethanol red. And at the end of the day, there was also a question relative to enzymes when going at higher efficiency with GMO yeast. As a GMO yeast is producing itself GA, of course, there would be a requirement for optimizing the hydrolysis. And there was another question related to please share later on if it is being used at commercial scale. Leaf GMO yeast is being used at commercial scale in the US, in Brazil, and in Thailand, in the two only plants that are operating in Thailand. And what we observe is that not only we get a benefit of 2% yield by the product itself, but when we start working on the hydrolysis optimization, we actually achieve much more than that, keeping residual sugar and residual starch within standards. And the last comment about that, we have been very humbled to be able to presenting these innovations today, but as Dr. Siba and Dr. Furqan mentioned, these are platform, and the new Evolve Evergreen is already identified, selected, and will be launched in India mid of next year. There was a last question that I wanted to address, which has not been raised yet about regulatory. Oh, then it is now addressed in the question. GMO yeast approved in India. What you have to consider is that each GMO yeast supplier will have to go for the registration for its own product. And each new product will have to go for the registration. As of today, GMO is globally accepted regulator-wise in India. And the reason why we can say that is because 2G ethanol plants have required GMO in the past, and we've been supplying our Silox 4 solutions into the 2G ethanol since 2021, 2022. The difference between 1G and 2G is when you are producing ethanol from 1G, you are having DDGS. What are the last requirements from the GEAC, from the regulatory standpoint as of today, to enable the utilization of GMO yeast for ethanol production is actually ensuring what is called a risk assessment and risk management procedures to prove that there won't be any residual of GMO product within the DDGS. And this is being done as we speak.
Okay, if we have more time, there were a couple of other questions, even with.
Hello, good evening, team Leaf. Myself, Neeraj Pratap Mal from Crypco Green Energy Private Limited. I have go through your presentation, and you are talking about the proactive approach 24/7 to the fermentation and liquefaction section. So, do the Leaf is Leaf providing any software solution, and how you are capturing the automatic data from the liquefaction, pre-fermentation, and fermentation section? Do you have any instrumentation approved by Leaf, or do you have any software so that the online data can be captured and proactive action can be taken for the improvement in fermentation section? Can you elaborate properly on that?
Yes, thank you very much, Neeraj. That's actually a very valid question. I will let Dr. Furqan, who has given the presentation about it, explain to you. Just a context about it, Neeraj, sir. Leaf is not an automation company. What we truly believe is that there is power in data, because once data is analyzed properly, we can actually improve the performances of the plant and even in some extent prevent proactively challenges in the plant. So the point of what we call the FCOE by Leaf, which already exists to answer one of the questions and which is already deployed in several units in India, is applying the expertise of Leaf 170 years backed up fermentation expertise in yeast and fermentation onto process data so that we can have a transparent, live, near real-time picture of whatever is happening. Even if I'm staying on the other side of the world, we could understand what is happening in your factory. And Dr. Furqan can elaborate on the technology itself, or at least on the phases to connect to the data.
Yeah, thank you, Chris, for explaining the basis of FCOE. Hello, Neeraj sir. This FCOE by Leaf is Fermentation Center of Excellence, where we have developed a digital tool which can be connected to the plant DCS in a PLC system, where it can take the data and then using our own tool, it can analyze and develop into valuable information which you can see near live, and also we can integrate this into a smart report which can help you to improve the performances. As Chris also mentioned, that it is not a automation tool, it is something that data is being collected and then used for the performance improvement. And yes, we have this tool deployed in many plants in India. And if you follow this slide, this is one of the example as how this tool looks like in a real time when you access the plant data, where you will have these three sections along with CIP. You can monitor your plant data near lifetime. So I hope it was self-explanatory. And agar aapko aur isme question hai, you can offline connect with us, book a meeting, or have a visit to your place, and then we can discuss further on this.
Thank you, Furqan.
Thank you.
There is one question I would like to address if we still have some time. Of course, there's I can see a lot of interest and questions about mass balance and how much can be manufactured for 100% of maize. What I would recommend for that is for you to connect Dr. Siba, Dr. Furqan, Chitrika. They will be in a very good place to explain to you all these details. Two questions that I wanted to address. Can we observe the data 24/7? Yes. What it's creating actually, it's an historian database that consolidates the data and that gives access to the data and all the historical data of the process. That's a very good question from the person who asked this question, because it means an ethanol producer can actually track the performances from years of operation and build specific models to predict what will be the fermentation. Another question was about sharing the PowerPoint and speaking about cost comparativeness for the innovation. Typically, the way Leaf approach the Indian market is whether there is a benefit in terms of yield, then it becomes interesting. And if there is no benefits in terms of yield, then there is no interest in using any additional new product. What we have observed in both Virtual Range product, especially Virtual Edge, which was presented today, as well as Evolve Evergreen that is being used currently in many plants, is a significant improvement in yield. And this improvement in yield makes a value that generates millions of US$ in a yearly basis. And this is far much more beneficial than the cost of the yeast itself, which is not even 1% of the total operating cost. I can see another question. I want to join with your company, with your team. Okay, thank you very much. I appreciate. No, leaf is not, Lesaffre, there's a question relative to manufacturing sites. If I can address this question, as I was explaining in the first few slides, our mother company, the Lesaffre Group, was created in 1853 and operates today more than 80 manufacturing sites worldwide. As Leaf being a business unit of the Lesaffre Group, we manufacture the leaf product in several of these plants. The GMO yeast is produced specifically in a dedicated drying facility in the US, in Dothan, Alabama. It's because we want to control the production of the GMO yeast. And for the non-GMO yeast, they are either produced possibly in Mexico, Chile, China, and or Indonesia.
Thank you. I think I can tell if time permits. So, Mr. Muhammad Hanif has raised your hand. You have a question here. You have, so it is written, by using evolved yeast, can we reduce other nutrients like urea? Because higher urea dosing will lead to generation higher alcohol like fusel oil. So can we reduce by using the advanced yeast? So maybe a tip. It's a good opportunity to discuss, and we can have a deep discussion if you want at your place. So urea is not exactly the fan, which we called, freely available nitrogen-free amino nitrogen. Uh, Yeast needs some enzyme in order to degrade this urea in to make a breakdown into the ammonium ion. Ammonium ion is something yeast can readily absorb. So in your case, if you think that fusel oil is getting generated, there is a chance that maybe it doesn't have sufficient nitrogen which yeast can absorb. For example, if you think that you are adding enough urea in your fermenter, but still you are having a high fusel oil. So one suggestion from my side, you can use some zinc. ओके आप थोड़ा जिंक डाल सकते हो 5-10 kg उसमें, बिकॉज जिंक इज समथिंग इज अ लिमिटिंग एलिमेंट जो आपको ईस्ट को जो एंजाइम यूरिया को ब्रेक डाउन करके अमोनियम आयन में कन्वर्ट करते हैं, उसमें सहायता करते हैं. इफ देयर इज अ लिमिट ऑफ जिंक, आप जितना भी यूरिया डालो वो यूरिया कंज्यूम नहीं कर पाएगा ईस्ट. जिंक नॉर्मली वी गेट फ्रॉम द कॉर्न एंड अदर फीडस्टॉक, बट समटाइम्स ये देखा गया है एडिशनल जिंक का थोड़ा बहुत रिक्वायरमेंट आता है. When you are adding booster, it doesn't have that zinc, and that time you can have this kind of issue. And regarding our yeast, which we have developed for the GM yeast, it is majorly working on the yield part, because we believe yield is the gold, and that part we would like to establish first. And using the process knowledge, what I exactly share with you, we can tackle your FO generation. Muhammad Hanif, if that is, answered your question.
Sorry. So Dr. S.K. Singh had a question for Furqan specifically. Maximum possible alcohol in fermented wash from non-GMO new yeast strain. So Dr. Furqan, could you please take that?
Yeah, thank you, Chiki, for the question. Okay. The alcohol content varies depend on what feedstock we are using. In India, we have limitation of running a higher DS specifically in maize. But the solutions what we have, not only the new yeast, but the ethanol red as well. We can go as high as possible. We have seen in different countries where the higher DS can be pushed to go as high as 17 or 18%. But practically what we can achieve in India is something we can think of, and we can work in that direction to have maximum fermentation ethanol in wash. But these strains, what we are using, ethanol red on the new platform, they're highly tolerant to the ethanol. It can be tolerated in a lab scale. We have tested up to 20% and so on. So it does not matter how much ethanol can be tolerated, but how much can be achieved using your plant. system what you have, be a PHE, circulation pump, or the mill's capacity. So these solutions what we have, the existing or the new one, be it GMO, non-GMO, they are very robust to have higher tolerance for the ethanol and higher tolerance for running very high gravity. And Dr. Siba has explained that our ambitions to work together to support Indian ethanol producer to achieve as high as possible final fermentation ethanol, so that the productivity is increased and the capacities are utilized. Thank you for the question. And we can connect also further on if we specifically work in your case.
Thank you, Furqan. I think Mohammed Hanif sir has his hand raised. So do you have a question? Oh, maybe not. Okay.
I think it was addressed already.
Okay.
I don't know if we have more time, but I've seen a lot of comments in the group. We've tried to answer a few of the comments. Please feel free to connect any person in this slide to go into the details, the calculation, and everything that we can do relative to whether it is GMO or non-GMO. I would like truly to take the opportunities of these 5 last minutes as we are closing this session to sincerely thank the GEMA Association for their collaboration and for giving us this amazing opportunity to share our vision. At Leaf, we've come a long way from Evolve, our first step into advanced performance innovation, to Virtuo, our next generation of non-GMO yeast range designed to bring measurable gains in yield and efficiency. And this is backed up together with a very good question that we had first about a digital platform solutions to better monitor, control, and improve the performances. And these innovations reflect our mission to turn data and science into real value for ethanol producer. The message is very simple from our side. With the right technology, digital insight, expertise, and partnership, incremental improvements become long-lasting performance gains. Thank you again very much to the GEMA and to all the participants for your engagement and all your questions. And I'm very much looking forward to meeting any one of you when spending time in the distilleries in India.
Thank you, Chris. Maybe Rekha, if you had something to say.
Yes. So with this, we are going to conclude today's webinar. So we are very thankful to Mr. Christophe Teste, Dr. Sibabrata Mukherjee, and Dr. Furqan Ali for a valuable knowledge partner. Please accept a token of appreciation from GEMA. Thank you once again. Thank you everyone for your valuable time. Good evening, everyone.
Much namaste.
Namaste.
Thank you, everyone. Namaste.
Thank you, everyone.
Thank you.
Thank you. Thank you.